is that the person who builds the model hands it off to some production team. This now involves, collecting requirements, having, various people, mocking up wireframes maybe, and maybe, you're using just a pure front end framework like React, and, maybe use a consultant, who knows. And the thing is that the app doesn't evolve. You end up having a situation where your release goes out, and then you have to keep repeating the cycle. If you want to change one thing, you need to put your requirements in. So it's not very agile to maybe go down workflow too. And so this is where Streamlit is aiming to be. It's the intersection of being fast and easy to create data apps. We like to say that it's the fastest and easiest way to create data apps, because you're basically taking Python code that you already have and you're decorating it with a handful of Python calls. If you think about how much of a model is data cleaning, once you kind of get through all of that, you may serve your model from an API endpoint or some other way. Once all that code is available, you might only need 10 or 15 lines of Streamlit calls to build a fully functional interface like you see here with the object detection. And the thing that we want to stress about Streamlit is we purposely made this an open source app framework, so that data scientists or machine learning or analysts, anyone working with data, can build a beautiful app in maybe just a few hours. And so there's three simple principles that Streamlit is built on around our design. First is going to be embracing Python scripting. So, as I mentioned, if you already are doing your work in Python and you have this analysis or model that you built, building an interface could be as simple as this st.write call that you have here. Okay, that call there does some markdown to put a title on the page, and then dot line chart does a plot. Obviously, this is a stylized example, but this is how you can put Streamlit into an existing workflow. Import the Streamlit library, works with all the libraries you might be using with pandas and TensorFlow and Torch, Altair, various things of that nature. And then, with just a handful of calls, you can build a user interface. The second principle of Streamlit's design is treating widgets as variables. And so one of the most difficult things in building a responsive interface is understanding how passing data between objects works. I'm not a JavaScript person myself. I've tried many times to learn, but once you start getting in a situation where there's callbacks and statefulness, and you're trying to pass information between different objects, it can get very confusing very quickly. And so what we've done with Streamlit is widgets that have a user interface function. For instance, this slider here, when you move this slider value along, its value gets written to a Python variable, in this case x, and however you switch this value around, that's the value that's returned. So when you're thinking about how do I incorporate the value from a UI widget to go somewhere else into my Python code, you literally just reference a Python variable, in this case x. So the st.write call is saying you selected, and then it dynamically changes each time you change the slider here. And then the third major design principle of Streamlit is reusing data and computation. And so, as I talked about before with callbacks and some of the kind of mind-bending stuff that goes on in JavaScript and other frameworks, Streamlit runs from top to bottom every single time you do something on the page. Now, if you think about that, some things you do want to be stateful. There's also situations like loading data sets or doing really expensive transformations or model fitting, where you don't want to constantly run these things over and over again. And so, whereas Streamlit's running top to bottom to make it easy to infer what the logic of the app is, you can selectively cache different steps within your Streamlit script so that those calls do not get recomputed. And so for you CS people out there, this is based on memoization. The concept that if you don't change the input to a function, its output should remain the same. And so if you label a function to be cached and you don't change its inputs, we just look up the value from the cache and return the value instantly. And so we may return, your 10 gigabyte pandas data frame, or your TensorFlow model, instead of constantly re-estimating and refreshing those things over time. And so with this top-down workflow and selective caching, you can get where you want to be in terms of a data app, quite quickly. And so that's just a high-level overview of what Streamlit is. For the second part, I want to actually go over the demo that comes with every Streamlit instance. And so to get started with Streamlit, you can do pip install Streamlit from your terminal. We do support Windows, Mac, Linux. And then once you have your environment set up, if you type in Streamlit hello, you'll see this demo. And so what I'm going to do here is actually do this live. Okay. I have a Visual Studio Code window open, and on the right-hand side, I have a browser. And this tends to be the workflow that I use when I'm developing Streamlit apps. And so I've already done all the installation. In fact, I can just kind of type in here what's in my content environment. You can see we have Streamlit here. And then we have a lot of the other common ones as well. So we have Arrow, Pandas, NumPy. So a lot of the common data science or scientific libraries are dependencies of Streamlit. And so you kind of get them all at once. And so if we run Streamlit hello, okay, the first thing you can see is we open up a browser tab almost immediately, and you get this welcome to Streamlit demo. And in the left-hand side in the sidebar here, we have a handful of different demos showing different functionality. Now, I'm not going to go over all of them. Obviously, one of the takeaways from this talk is that you can go do this yourself. So let's go over just maybe we'll go over the data frame one, for example. And so this is the general process, or what the general outline of a Streamlit app looks like. We have, something, some sort of title or explanation, anything you can do in Markdown, you should be able to do in Streamlit. And so, we have links to where the data websites are. We can choose different countries. And so if we're looking at gross agricultural production here, as you can see, I'm going through this text box, okay, that itself is using a pandas function to get the unique values. We're displaying our data frame here with the data. And then this is an Altair chart that shows the gross agricultural product, for these different countries. And so it really can be as easy as that. If we want to be able to have an interactive report that shows people how to, gives them the ability to interact with the data set, they don't have to know Python. They don't have to be able to generate this themselves. And down here, you can actually see what the code looks like. And you can see there's really not a whole lot going on here. You can see the ST cache statement that I was talking about before. So we download the data one time from S3. And then, the multi-select box, again, is literally just, making a list out of our data frames index. Then we can kind of go through just normalizing the data, do a little bit of data pre-processing here. And then we have an Altair chart, which we display with st.alterchart. And so, that in itself is really the baseline for getting started with Streamlit. You don't have to think about callbacks or how do I pass data between different areas. And, as I mentioned, each of these UI widgets returns a Python variable. And so st multi-select here returns an object countries, okay? And countries, in this case, is going to be the countries that are selected in the multi-select box, okay? And as I said, there's 4 different ones here. We have a mapping demo that uses PyData, which is a wrapper around DeckGL from Uber. And so, you can do interactive geospatial visualizations. You can, obviously, you can scroll in and, see various parts of the map. We have real-time plotting demos here. And so if you wanted to have a website open and, just constantly go through and refresh the data, we make this very simple. In this case, we have a method that we've added to all the chart types called add rows. And so you can just constantly append data to the chart. The chart itself re-renders, but because we're using Altair, which is based on Vega Lite, another JavaScript plotting framework, only the pieces of the graph that change get re-rendered. And so you get this very fluid situation where it looks like you're continuously adding data to this chart, but in fact, the number of the lines of code or the way to do this is actually quite simple. And so, so I would highly encourage anyone who's interested in Streamlit to first check out these demos. They're intended to be very accessible for users. They also show how to use quite a few of the different APIs and UI widgets that we have. And so, as you try and build a toy example for yourself, definitely check this out to see some of the better practices and to get ideas about how you might do a real-time app or a geospatial app, or make an interactive report with data frames and plotting. This is a great place to start. Now, with that, I actually want to try doing a live coded demo to just really, again, reinforce how what it takes to get started with Streamlit. And so I'm going to actually close this down. And then I'm going to use a blank Python code, a blank Python script. And so to get started with Streamlit, we support using Python scripts. Okay, so we don't really interact with the Jupyter Notebook cells model. A lot of the things that we refer to in our documentation as magic kind of refer to the ability that you can rerun a script over and over again, as opposed to cells, which are somewhat disjoint in a notebook. And so it's just something to keep in mind. If your preferred environment is Jupyter Notebook, this is going to be a little bit maybe different than you're used to. If you're using Jupyter Lab, it does have the ability to have Python scripts and a terminal window open, which is approximately what Visual Studio Code is right here. So if you're familiar with Jupyter, you can use it, but you can't really use it in that cells framework. Okay, so now if we run Streamlit run, and I'm going to do live code zoom.py. And this, just as an aside, I already posted in the chat window the code for this demo on GitHub. And so I'm going to approximately do it here live. But if you want to go back, or if you want to follow along right now and do this, you can go to the GitHub link that's in the chat and kind of follow along. And so the first thing to know about creating a Streamlit app is importing Streamlit. So the convention we tend to use is import Streamlit as ST. And then what you'll see over here on the browser side is a little warning saying the source file changed. And so what do you want to do? Since I'm in active development, I'm going to say always rerun. So now what we have is a base Streamlit app, and you can't really see anything except for maybe this top color line here and maybe with Streamlit. But as we move along, we can go through and have very fluid development. So let's add a title. Okay. No sooner than I hit save in my text editor, we've already reloaded the Python script, sent the text over to our app, and everything's reflected instantly. Obviously, writing markdown text isn't particularly computationally intensive, and so we wouldn't expect to see anything other than instantaneous results. I'll show you in a little bit about caching and things, which I think will really reinforce how you can use control logic to get the exact user interface that you desire. And so now that we have this, I'm just going to put a quick horizontal line here, okay? And so again, this is a markdown thing. Any string that gets provided just sort of outright within a script, Streamlit's going to analyze the data. It's going to go through and say, okay, well, if you're putting a string like this, you must mean markdown. We have quite a few of these defined for different types of Python objects. And so if you just submit a data frame, we'll print out a formatted HTML table for you. Or if you return a matplotlib plot, we'll show that plot on the screen. And what you'll find is that this ends up being a very convenient interface, again, for working rapidly. And so here, I'll just add another markdown heading. And then something I like to do when I'm either doing teaching or live coding is use a method that's called stecho. And then right now I'll just type pass. And so as you're going through building your demo, obviously I have this code on my left-hand side of the screen. On the right-hand side of the screen, not only are we going to have a user interface that constantly updates, it's actually going to show you the code that we're running to get the user interface on the screen. And so the first thing that we can do maybe is just, let's do a slider example. Okay. And again, right away, we get refreshing. And so if we're creating a slider, okay, we might do something that looks like the following. First, we put a header to give a user a hint about what you want them to do. And so maybe we'll pick a number between 1 and 100. Okay. And just as quickly as that, we've declared a slider interface to our inside of our app. And so we can move this around. Up in the right-hand corner here, you can see occasionally it'll say running for just a brief second. And so we've declared a slider interface, but we can't really see anything from that. We can take it for granted that slider 1 actually has this value, or we can actually prove it. And so you can use things such as f strings to actually display data. And so the number So within 10 seconds, we've created a slider interface, and we're already able to pass this data along and have a dynamic interface within our app. And so this ends up being very powerful because no matter what you want your app to look like, you're essentially putting these user interface elements on the screen, and then you just have to think about them as Python variables on the code side. Now, you might want to do something, say like, I don't necessarily want a slider right here. And so we also support a sidebar interface. And to make this easy, instead of trying to make people have to really think about what the syntax might be, almost all of the user interface elements, if you add sidebar as the second level to ST, you can go ahead and copy them over into the sidebar. And so let's do a second one. I don't know, we'll just call it sidebar slider. Okay. And again, as simple as that. So what's actually interesting here is I made a mistake. So I actually wanted to put this on the sidebar, but as you can see, I put this script here and it put it in our main app. And so if you want to actually write this to the sidebar, okay. So again, now we can move this slider here. Nothing's happening in the main app, or nothing actually looks like it's happening. And I think this is an important distinction. When we run this, Python's running from top to bottom each time. So even though this doesn't appear to be changing, this is actually rerunning. React on the JavaScript side is saying nothing about this changes. So from a practical perspective, this interface doesn't change. But now you can actually do something kind of silly. Suppose we wanted to just say like, okay, let's set our value not exactly sure why you might do something like this. But as it turns out, you can use one widget to control another. And again, because we're passing around Python variables, even though you might not actually do this in a real example, it's very easy to tie widgets together, to be able to dynamically create text. All it is, again, is a handful of simple Python functions. So as a second example, okay, actually, let me, before I do that, okay. Suppose we want to display some data. People usually do this in a couple of ways. I'm going to import NumPy. So we can create a data frame that has 100 rows, 3 columns. As I mentioned before, because Streamlit is focused on productivity for the app developer, we've gone through for a lot of common data types and defined methods of what you mean. And so if you were to do this in a Jupyter notebook, it kind of works the same way. You can write a bunch of code in a cell, and then when you refer to the object itself, it returns a nice representation of your data. And so we're kind of using that same process here. And so if we want to display data, we can go through and just do something as simple as declaring df. You don't have to write df, or you don't have to define a bunch of methods to make the data work. You automatically get this very easy interface. Now, as we go through, what happens if we change our sliders here? Okay, so this is where you start to realize, that the script is running from top to bottom. Okay? And so while this is easy to understand, this may not be the actual behavior that you're looking for. And so we can actually do this as caching. And so if we want to do that, let me just make a header real quick. What we can do is define a function and let's assume that we want to actually generate a different number of columns. We want to make this selectable. And so what we can do is this is always the struggle with live coding. So what we can actually do here is we can create a simple function, and then we can return essentially the same code as up here. Okay, but instead of 3, we want to have calls. Okay, so now we have a function. This is again basic Python. There's nothing Streamlit specific about this here yet. We have a function where we pass a number, an integer, to get ran data, and we get a data frame back. And so if we want to keep this, well, before we do the caching, let's actually define this. So df2
Randy wanted a reminder that we're a few minutes for time, so you want to leave some time for questions.
Yep, I'll be done in a little bit. And so, okay, we have the same situation here. You can see as we move the interface, our data frame is changing, just like this one is, right? If we change this interface here. Now, suppose instead of doing this value here, we said, okay, let's base this on the slide bar, or the sidebar slider. And so that's slider 2. Okay. So now we can actually decorate this with a cache variable. And so what we see is when we move the sidebar slider, our data frame changes. Okay? But now you can see this one has been cached. Since we haven't changed the value here, no recomputation is happening. We're going through, we're looking up the value for 47 columns, and we're returning it instantly. And so this may seem like kind of magic, and very frequently it can be a little bit mind-bending. And so the most important thing here is, again, to remember that Streamlit process is top-down, and you go through your process as if you had a new environment each time. And so Streamlit doesn't suffer from the same issue, potentially that you can have a Jupyter Notebook, where you can move the cells around and run them out of order and potentially be in a weird state. Every time you save your script on the left-hand side in Python, you're going to start over. If you don't want that behavior, that's where stcache comes in. Since we're running out of time, I'm just going to briefly go to another demo, not explain it very well, but just kind of show you something new that came out with Streamlit 0.63. So for our July release, we released a framework for allowing users to create their own components. And the great benefit of this is now users are even further empowered. Whereas before, you may have been waiting on Streamlit developers to incorporate your favorite library. Streamlit components now allow you to take the output of any arbitrary library that you want and decide whether to have either a static component like this one, which means one directional communication from Python to the browser, or you can actually create bi-directional communication where Python writes to the browser and the browser actually returns values to Python. And so at this point now, potentially any library that you're already familiar with in Python, especially if it already has Jupyter Notebook support, you can actually use within Streamlit, assuming that you wrap those calls a little bit so that we can understand what the output is. And of course, we highly suggest people, create their own Python packages out of this. Like for example, there was a lot of demand for Folium, which is a geospatial library. So I created a Streamlit Folium component for people to look at. And with that, I definitely want to leave some time for questions or comments. And thank you all for listening.
Thank you, Randy. So anybody question? I saw there's one question on the Q&A. So do you have a material on the website that explains how to use Jupyter Lab with this?
Yeah, so we really don't. This is one of those things that I mention when I give talks because it's a bit confusing. Since we don't interact with the cell model, we don't spend a ton of time actually referring to Jupyter anywhere in our documentation. For Jupyter Lab specifically, in the header, you can actually create a terminal window and you can put it next to a Python text editor window. You'll get the same effect that you would get from my setup of Visual Studio Code, and that's how you would run it. And so you would type your code in the Python window. In the terminal window, you'd write Streamlit run, whatever your Python, app.py, and then it would open up another tab in that same browser, and it would show you your Streamlit app.
So I've got a question for you. So so I know the Streamlit is working for team versions, so basically not individual, just individual. So so what the main features of the team will have?
Sure. So one thing that I alluded to in the slides portion of my talk is that you can be a data scientist or an analyst or whomever you might be, is probably not the person who is used to putting things into production. And so creating an app is one thing, but sharing with other people is an entirely different skill set. And so to extend the Streamlit idea of making things simple for the user, Streamlit for Teams is going to be a commercial product that we release. There is going to be a free tier similar to other competitors in the marketplace. And what we're aiming for is actually one-click install. So if you have a GitHub repository that has a valid Streamlit app in it, it's our goal that you'll actually point to that URL, tell us which file the Streamlit app is in, and then hit send to production, essentially. And then that will provide you with a URL. This is going to come out later this year. I can almost guarantee it'll be kind of Q4 or later. We'll start out with a beta program, as I mentioned, for smaller usage and to help us kind of build the architecture and make sure we're incorporating the features people want. There will be a free tier, that we do expect that to continue on. I don't want to say indefinitely, but we expect at least that there will be a free tier for people to share their analyses. Maybe people are doing, COVID-19 dashboards. things that are public data or public interest, that's what the free tier will be for. We will eventually launch the commercial piece, which will have, essentially abstract away cloud deployment. And so you'll work with us for some, amount of service fee per month. And you have that one-click deployment, that will support actually private apps and login and security type issues if you want to keep your information private. And so it's a long-winded answer. Streamlit, there's two pieces of Streamlit to keep in mind. There's Streamlit, the open source project, and there's Streamlit, the company. We happen to be the same people doing this. Streamlit for Teams will be the commercial part that goes along with the company. That is how we will hopefully further fund work on Streamlit, the open source library.
Great. Anybody has other questions? If not, we're gonna open up the time for all the both talks, Jim's and Randy's talk, for any other questions if you have. We have maybe a couple of minutes. I guess not. So if not, I'm going to just quickly mention about our coming up events. So at the San Francisco Big Analytics. So we have a few events lined up for the coming weeks and months. So the next one is August 13th on the two talks. One is the introduction to Apache Kali, and the other one is the missing story of a columnar format given talk by LinkedIn. And then August 25th, and there will be introduction and it's another minor talk, meaning within the language it learned. So a magnetic shuffle service, it's kind of push-based shuffle at LinkedIn. How do they do that in Spark? So we have another one which we haven't really announced. That'll be late, maybe early or late October. Talk about the ILP type of framework. So so stay tuned for those talks. Okay, so with that, we'd like to thanks Randy and thanks James to give these great talks. So the recording will be shared on the YouTube video later. I'll put a link on a meetup page. And we also like to special thanks to AI Camp, Bill Lill, who provide the Zoom for us. So thank you for attending. We'll see you next time.
Great, thanks for having us.